going over the Chapter 8 review. This is Part 2. We're going to do numbers 7 through 10, which is just a quick review of the parent functions of these things. These are parent functions. Number 7, is the parent function of a line. We learned how to build a table, graph, and all for a parent function of a line. It's actually on page 97, but 97A tells us how to build a table and graph. More specifically, the parent function of a quadratic is number 8, y equals x squared. That is called the parent function of a quadratic. It was investigated on page 194, and then we very specifically learned how to build a table for quadratics on page 195A. Y equal 2 to the x is the parent function of an exponential graph. We investigated it on page 184. Y equal 1 over x is the parent function of a rational graph. We investigated it on page 241. Y equal x, the parent function of a line. To build a table, we would start with x because it is the domain or the independent variable. We solve for y because it is the range or the dependent variable. We put what y is equal to in the middle. For x, we're going to choose -2, -1, 0, 1, and 2, unless the slope is a fraction, in which case we would choose multiples of the denominator for x. And I'm quoting page 97A. Well, this had a understood slope of 1 and y-intercept of 0. You can study that on page 97, example 1. We're going to put in for x the value of x, and it's going to kick out the same y because y is equal to x. So whatever you put in for y is what it kicks out for x. We could plot those points on a coordinate plane. These may not come out exactly perfect because I'm going to draw my little grid myself. The first point was -2, -2. The second point was -1, -1. I stayed in that spot too long. I need to tap it instead of stay on it. -1, -1 would be there. 0, 0 would be there. 1, 1 would be there. 2, 2 would be there. And we would draw the line. That's the parent function of a line. Its slope is 1, its y-intercept is 0, and it bisects quadrants 1 and 3. The parent function of a quadratic, we could get real fancy in finding the slope in the line of symmetry in the vertex. But the parent function is pretty easily done by just choosing those same old faithful values. If it's a complex quadratic, then you're not going to want to choose those old faithful values. You're going to use the page 195 drill. If we plug in the old faithfuls, we get -2 quantity square. We learned that it had to go in parentheses square on page 170, I believe. Maybe 171, one of those two pages. I believe it's 170. -1 quantity square, 0 square, 1 square. When it's not a negative, it doesn't have to go in parentheses. So we're going to get +4, +1, 0, 1, and 4. And we start seeing this reflection concept that we get the same y's again. And that's why it's going to look like a parabola. And so we're going to graph. We have the point -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And you can see that the graph is kind of a U-shaped thing we call a parabola, and it should be symmetrical about the y-axis. In other words, it should be the same distance here as here. So I didn't do a real good job of graphing that uh, because my ditto marks weren't the same. But it would look something like that if we had all our points in the right spot. Okay? Y equal 2 to the x is exponential. The thing we have to remember about exponential is the negative on the exponent reciprocates it. And so we have like 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the first, 2 to the second, 2 to the third. 2 to the negative 1, 2 to the negative 2 means the reciprocal of 2 squared. 2 squared is 4, its reciprocal is a fourth. 2 to the negative 1 means the reciprocal of 2 to the fourth, 2 to the first. 2 to the first is 2, its reciprocal is a half. Any number to the 0 power is 1. What I'm quoting here as far as these rules are coming off of page 13 where we first learned about exponents. The negative on the exponent reciprocates it. Any number to the 0 power is 1. Any number to the first power gives you that number back. All of those rules are on page 13. 2 squared is 2 times itself, which is 4. 2 cubed is 2 times itself 3 times, which is 8. We'll do a graph of that. And so we have the point negative 2 and 1/4, which is kind of hugging it right in there. And we've got negative 1.5, which is up a little more. We got 0, 1, which is there, so we can see we're climbing faster. We have 1, 2, so now we're climbing, 1, 2, so now we're climbing really fast. And then we've got 2, 4, which is even a better jump. And then we've got 3, 8, which is way up here. And we see that we have an exponential growth curve, which is beginning to get really high, really fast. And then number 10 is a rational. And we recall on a rational that we need a whole truckload of points, and that had a lot of fun getting crooked on me there, didn't it? If I can go slow and nope, it's not going to stay where I'm writing, but that's okay. We'll leave it all kind of wumpy jog. So we got a y, we've got a 1 over x. We're going to choose things like -4, -3, -2, -1, 0, 1, 2, 3, 4. Then we're going to throw in some fractions like -1/3 and -1/2 and +1/3 and +1/2 and just get a whole gob of points because we know this thing is opening up twice and going all over the place. So we have 1 divide -4 is -1/4. 1 divide -3 is -1/3. 1 divide -2 is -1/2. 1 divide -1 is -1. 1 divide 0, division by 0 is undefined. 1 divide 1 is 1. 1 divide 2 is a half. 1 divide 3 is a third. Now we throw in 1 divide 4 is a fourth. We throw in those fractions to make something pretty happy. 1 divide -1/3. To divide by a third, you multiply by the reciprocal 3. So really have 1 times -3, which is -3. 1 divide -1/2. Divide by -1/2 is the same as times -2. 1 times -2 would be -2. So 1 divide -1/2 would be a -2. Same 1 divide 1/3 would be the 3. 1 divide 1/2 would be 2. And so we have just a gob of points. And I'm going to erase some of this other stuff or white out over it just so we can get a look at that rational. Before we do, let's kind of look again. A little bit of summary. Y equal x is the parent function of a line. It bisects quadrants 1 and 3. Y equal x squared is the parent function of a quadratic. It opens upward with about the steepness you see. The line of symmetry is the y-axis. The vertex is 0. Y equal 2 to the x is kind of like the basic parent function of an exponential. It approaches the x-axis but never hits it, and then it goes up into positive infinity. Y equal 1 over x is the basic rational. To get a data table, because it goes all over the place, we need some negatives. We need 0. We need some positives. We need some negative and positive fractions also. And we'll just get points that go all over the place. And so now that we've summarized these, I'm going to move them out of the way so that we can focus on plotting those points and getting a nice, pretty rational graph. In fact, I think what I'll do is go ahead and bring in an axis for this one. That would be nice to import one. We'll see if we can slide that over here and get our writing back. But when we get our writing back, we lose our graph because we whited out over that whole spot. Yeah. This is interesting. Well, we'll just remember all the answers. How's that? So we're going to lose all of that writing and just remember our answers. Negative 4 turned into negative 1/4. Negative 3 turned into negative 1/3. Negative 2 turned into negative 1/2. Negative 1 turned into negative 1. 0 was undefined, which tells us that that curve is approaching the y-axis and never hitting it. It's called an asymptote. We can see that this other's approaching the x-axis and never hitting it, so it's another asymptote. When we plugged in a positive 1, we got a positive 1. When we plugged in a positive 2, we got a half. When we plugged in a positive 3, we got a third. When we plugged in a positive 4, we got a fourth. And so we were ever so closely approaching the x-axis. Then when we plugged in the fraction negative 1/3, we got a negative 3, which is about right there. And when we plugged in a negative 1/2, we got a negative 2, which is about right there. When we plugged in a positive 1/3, we got a positive 3, which is about right there. When we plugged in a 1/2, we got a positive 2, which was about there. And so what we see is that we have a graph that is ever so closely reaching that x-axis but never hitting it, and then come over here and ever so closely hitting the y-axis but never hitting it, reaching that y-axis and never hitting it. Same thing here. It's ever so close to the y-axis without hitting it, and then it draws away, turns, gets ever so close to the x-axis without hitting it. And so there's the graph of y equal 1 over x. Okay? Any questions on the Chapter 8 review? You need to study that word parent function. You need to be very familiar with what the parent function of a line is, what its table looks like, and what its graph looks like. The parent function of a quadratic, what its table, graph, and equation look like. The parent function of an exponential, what its table, graph, and equation look like in a rational. You'll also learn about a square root in Chapter 9, and you'll learn about absolute value in Chapter 10.